delivered a similar talk in Bangkok, which took an hour and a half, I was persuaded to modify my talk. So goodbye to the coming revolutions. Instead, I will talk about the lessons of science, a broader talk about what science has brought us and what it will, and some of the deeper lessons we have learned from the successes of science over the last few centuries. Science is a rather new human endeavor. Human culture is hundreds of thousands of years old. It's only in the last few centuries that we've unleashed the power of science. I will talk about some of the lessons we have learned in these centuries, starting with the scientific method itself, a different way of looking at the world, which has not only proven extraordinarily valuable for unlocking the secrets of nature, but I think teaches us a lot about how to conduct human affairs. Of course, the main product of science is knowledge, and I'll discuss very briefly some of the incredible advances we have accumulated over what is maybe the lifespan of 5 or 6 people put length to length. This, of course, has increased enormously our control over nature, with consequences both good and bad, and I'll discuss some of those, as well as how we are going to solve some of the problems that face us. And there I believe that what will be necessary will be a kind of internationalism of a sort we have not yet seen, and that itself is modeled by scientific society and can follow its example. And finally, since science is based on asking questions of nature and making predictions about nature, I'll end with some perhaps provocative questions and predictions. So let's start with the scientific method, which is a rather new way of thinking. It's only a few hundred years old. And it is based on the surprising idea that the best way to achieve understanding is to observe and experiment and to subject all of our ideas to observation and experiment, which are ultimately the judges as to whether our idea is correct. In fact, the only authority for truth, in science at least, is agreement with nature through observation and experiment, not political power or religious power. Parliaments cannot repeal the law of gravity. The Bush administration cannot deny global warming. This is an extremely important lesson and has profound implications for human culture and politics. And finally, all of our scientific theories we have learned are provisional. There are no absolute truths. We must continue to subject our ideas to continual quantitative test and improvement, and to expect that we are probably wrong, maybe only slightly wrong, and maybe our theories are a very good approximation to nature, but we all expect that ultimately we will have to revise them. Science is inherently is inherently built on skepticism. And we have learned that in order for science to succeed, we must have openness. Scientific findings must be available to all, and we must, if we're to be successful, allow anyone to contribute to the advancement of science. It's for that reason that a healthy scientific culture requires an open society. And science itself and the pursuit of science promotes tolerance. To be successful in science, we must allow people with different points of view to air their ideas, because often they are right and the establishment of science is wrong. So we have learned to construct a scientific culture which is open and tolerant. This just illustrates the expanding scope of our knowledge of the universe, from our planet to the solar system, each time a factor of 1 billion, to the galaxies, to the universe as a whole. Notice, if you look at the universe as a whole, that part that we can see, it is very homogeneous, as it was 13.5 billion years ago. This is a picture of the radiation that was emitted 13.5 billion years ago from the hot gas left over from the Big Bang, and is reaching us 13.5 billion years later. We have in fact mapped out the history of the universe from close to the beginning until today, and understand in great detail how it evolved, how the little fluctuations in that hot gas way back then clumped together and produced galaxies and stars and planets. But we still find one enormous mystery, the Big Bang, which started the whole thing going. And there, we still do not understand what went on and are pushed further. Biology. Here, this is the youngest of the sciences, in a sense, and one where the serious advances only began in the 19th century. But how far have we come so fast? Over the last 150 years, we have learned that life emerged over 3 billion years ago and evolved by mutation and natural selection. We located and deciphered the genetic code and outlined the basic mechanism of living cells, discovered the cause of disease. And finally, we have localized the source of consciousness and emotion in the brain and have started to explore its mysteries. It began with Darwin, who had a wonderful, and as it has turned out, enormously successful theory in which he explained the changes and evolution of life as proceeding via natural selection, and demonstrated by meticulous observation how that can produce all the variations of living matter. By now we have mapped out an incredible history of life on our planet. 3 billion year history with an incredible variety of different species. We, of course, are a very late comer in this history, have only appeared very recently. But one of the most important lessons we've learned, not just for science, but for human culture and politics, is that all humans have a very recent common ancestor and a common origin. Life has been on the planet for 3 billion years, Homo sapiens for more than 1 million years. But all of us had a common mother and a common father, different. They weren't necessarily married or even lived together. But there was a bottleneck in our evolution. We all came from a common source only about 150,000 years ago from somewhere in Africa. And we are beginning to map out how this single human family has spread over the world in this very short time. This lesson that makes all racial bigotry silly and obsolete hasn't, I think, totally sunk in around the world. We're all related. It is silly to talk of one's recent relatives. We're all very closely related. In the last 50 years, we have made extraordinary advances in biology, as we did in physics, in understanding the microscopic structure of life, how the cells work. These, by the way, are stem cells. The genetic code is embodied in the nucleus of each cell and contains the information necessary, the blueprint for all the functions of all the different cells in our body. It does so by producing RNA that creates proteins that do the work of the cell. And we're now ready to truly construct a quantitative understanding of the function of life based on this microscopic structure. For the benefit of mankind, we learned that disease is caused by bacteria like this, viruses, both of which we know how to control to some extent, and by genetic mistakes, which we are learning how to control. And finally, we have discovered that the locus of thought and emotion, what makes us human, is in the brain. And the brain is just a jungle of 100 billion interconnected neurons, and we are beginning to unravel, but just beginning, the microscopic structure of how this collection network of neurons work. Eventually, we will understand the origins of thought and emotion. So, this has given us enormous control of nature. Basic science inevitably leads to greater control over nature and unpredictable new tools. It cannot, what use basic science will be is not something that can ever be predicted. But it always happens, and the new technology that science has produced has been of immense benefit to humankind, but also presents grave dangers. Of course, science had its first enormous impact on human civilization by underlying the Industrial Revolution with a steam engine, electricity, and magnetism, and now the application of quantum mechanics to modern technology, which has given us things like instruments of communication and calculation beyond anyone's imagination just 50 years ago. But along with all of these benefits, including the benefits of medicine, which have produced drugs, imaging techniques, and many other advances that have led to the doubling of the lifespan of humans in the last 200 years. So today, each of us has 2 lives because of the advances that science has made possible. But in addition, science has led to, through all of this power over nature, to powerful and awful weapons that have given us for the first time the ability to destroy the species. And now, perhaps even greater threats to the health of our beautiful planet. Science has doubled the lifespan of humans, which is great. and has eliminated disease, or many diseases, and that's wonderful. But as a consequence, the human population has taken off like a bomb. If you extrapolate this curve, you discover this curve fit very well till the year 2000. This curve becomes infinite in 7 years from now. Now, people think that's not going to happen, and rather we will level off with a world population of somewhere between 9 and 15 billion people. But that's a lot of people for our small planet compared to the 1 million or less that we've had for most of our existence. And those people are demanding more and more and more. So the global energy conservation is tracking, in fact, is expanding more rapidly than the population growth. And you'll notice that most of this consumption of energy is using fossil fuels, oil, coal, and gas. And as the whole world is beginning to realize, this has dramatic consequences on the planet, especially on the temperature of the planet from CO2 emissions. As this is from the IPCC report, this is the UN committee that won the Nobel Peace Prize this year for their work on global warming, and tracks the rise in temperature, which you see just takes off in the year 2000. These are their projections for the next 100 years with various assumptions. Assumptions as to how we, as a world, respond to this crisis. But the numbers are frightening. These might seem like small numbers. These are the increase of air temperature at the Arctic, 2 degrees, 4 degrees, up to 8 degrees by the end of the century. And what causes that, of course, are carbon emissions. If you track the temperature change, you see that it tracks very well the amount of CO2 that we are putting into the atmosphere. There is by now no question that human efforts, human activity that leads to increased CO2 emissions into the atmosphere is contributing to this rapid global warming. And what are the effects of this global warming? You might think that 1 degree rise in temperature isn't so much. But 1 degree, already with our current warming, we have less water available, more drought, wildfires, floods, storms. With a 1 degree increase, there will be a risk of extinction for 20 to 30% of the known species, and most corals will turn white. With a 2 degree increase, there will be major changes in natural systems, widespread death of coral reefs, and millions of people will face flooding risk. With 3 degrees, there will be a substantial burden on health services, and 30% of global coastal wetlands lost, and a decrease of global food production. With only 4 degrees, more than 40% of known species will be extinct, and economic losses, GDP losses, will be up to 5%, and there will be at least a partial meltdown of the Greenland and Antarctic ice sheets, raising sea levels by 13 to 20 feet. And remember, those projections went all the way up to 8 degrees. This is a picture which shows you quite visually what is already happening with the Greenland ice sheet and coral bleaching. Science can and must help. There are all sorts of places where breakthroughs might occur that will help us solve some of these problems, but more than science is needed. We must, I believe, build an economic and political system that is not dependent on unlimited consumption and growth. I am very disturbed when I hear politicians, certainly in my country, talk about global warming, because they always say, we can deal with this problem and still grow and consume more and more and more. Politicians don't know any other way to appeal to the masses anywhere in the world without promising them more growth, more goods, more consumption. If we continue to base our societies on consumption, consumption, consumption as the ultimate human goal, then I think we are doomed, no matter how much we become energy efficient. We have to find some other way of building an economic system and a political system where politicians can run for office without promising more and more material goods. And finally, we must move towards a world government. We're all one family. The problems we face are of the planet as a whole. The economic system is more and more a world economic system. The idea of having 150 separate governments is crazy and is not going to last, I believe, that long. And we must move as fast towards a true world system as possible. And here's where science can provide an example of internationalism. You see, the problems posed by basic science are not posed by governments or national organizations or politicians. They're posed by nature. And in the pursuit of science, everyone is equal. So for that reason, basic science is and has always been a truly international endeavor, a wonderful model of cooperation, collaboration, and of course competition, which is important and useful across all nations. I found a letter that Einstein wrote to an organization right 1946 after World War II, when he was concerned about nuclear weapons, the atomic bomb, and how it could destroy civilization. And Einstein said, "The growing movement of a supranatural government seems to me the major hope of mankind. Only world law can assure us progress towards civilization, peace, and true humanity." We were lucky to avoid nuclear annihilation over the last 50 years, but we might not be so lucky to avoid what we're doing to our planet. And I agree with Einstein that internationalization is what is needed. So let me end with questions and predictions. Questions are absolutely important because I like to say that the most important product of knowledge is ignorance. Not ignorance of the type that leads to bigotry and racism, but informed, intelligent ignorance. That's what propels science forward. You see, knowledge has this geometry. We're embedded in a sea of ignorance, pushing our way out. And all of the interesting questions arise at the boundary between knowledge and ignorance. So the more we learn, the more knowledge we acquire, the better questions we can ask. And so one of the great resources of science is informed, intelligent ignorance, the questions we ask today that we hope will be answered tomorrow. And we have so many wonderful questions that we are working on in the basic sciences. How did the universe begin? That's a great and wonderful mystery. It now is a legitimate scientific inquiry which we are addressing. The universe we've discovered is full of something we call dark matter, which we can feel but not see. Most of the matter in the universe is in this form. We don't know what it is, and it is full of a form of energy, vacuum energy, that is causing its expansion to accelerate and whose magnitude we do not understand. And all of those forces that we do understand seem to cry out for unification. How do they unify? Some of us are working on a wonderful attempt called string theory. Is it the answer? What is the nature of space and time? We are being led to question our classical concepts of space and time. Something happened to my presentation. In biology, one of the most fascinating questions that we're beginning to address is, how does consciousness, thought, emotion, free will arise from the collective behavior of 100 billion neurons? And many, many, many more wonderful questions. Some of these we will answer. We have wonderful tools to answer them. This is a picture of a massive new particle accelerator which is turning on in Geneva in Switzerland next year and will help physicists understand, we hope, many of the mysteries we still do not understand about the unification of the forces. In the case of cosmology and astronomy, we have marvelous instruments like the Hubble Space Telescope that we send into space to explore the universe. I'm going to end with a bunch of outrageous predictions. It's very dangerous to make predictions, but the business of scientists is to make predictions. So over a period of 50 to 100 years, it's easy for a basic scientist to predict that most of the questions that we ask today will be answered. I don't know how they will be answered. I wish I knew. They seem impossible, some of them, to answer. But history has shown us that almost any question in basic science we can ask fruitfully today is answered over a 50, 100-year period. So all those questions I asked before, except maybe how did the universe begin, that's perhaps the toughest, including the nature of the mind, will be answered, I am convinced, over this time period. But we will have even more interesting questions to ask and to ponder. Questions I can't even ask nowadays because I'm not intelligent enough. I don't know enough to be ignorant. But I also think that one of the major developments in this time span will be that as we learn how the human mind works, the social sciences, the political sciences, economics, the sciences that depend on human behavior might become real sciences, quantitative sciences, sciences that have a microscopic understanding to build on, in this case, how the human mind works. And that could have enormous advantages It might enable us to move towards better and more rational societies with the application of the human sciences to human behavior. And with that, we might then be well on our way towards a sustainable economic and social arrangement and a world government. You know, the planet is 5 billion years ago. It's 5 billion years old. Life is 3 billion years old. Humans are millions of years old. So, it is always, I find it always interesting to imagine what will the world look like, what will we as a species look like in 1,000 years from now, which is a very short time, but unimaginable. There's no way I can predict the issues of basic science then, or technology, but I'll make some predictions anyway. What I mainly would like to predict is that the problems we face today, and which I believe we will solve, of sustainability and the threats to our environment, will be replaced by other problems that will also partly emerge because of our increased control over nature. Some of them won't be. They'll be the two-edged sides, two-sided nature of scientific advances. The first is increased lifespan. The human lifespan has doubled in 200 years. What will it be 1,000 years from now? Well, it's hard not to predict that it will increase by a factor of 10, maybe even more. That is wonderful. We would all like to have 10 lives, 20 lives. It's crazy to have a world in which we educate young people like you until the age of 25 and 30 years of growth and education, and then you work for 30 or so years and then retire. What a waste! An increase of lifespan by a factor of 10, I think, at least, is inevitable and desirable. But, of course, it would have profound impact on the environment, on society, on our culture, and this would be a major crisis. Good and bad effects of knowledge. A more wild prediction is that as we begin to increase our control over the genetic code and to do genetic engineering, which we will do, we will change our genome so as to eliminate disease and then to start improving ourselves. We face the danger, enormous benefits, increased lifespan, elimination of disease, increase of intelligence, who knows? But we also face the danger of speciation. This is directed human evolution which we carry out, and it can cause our splitting, the human Homo sapiens splitting into different species. Is that good, bad? Can we live with it? I sort of think it is inevitable if you look at the 3 billion year history of life. And finally, at this period of 1,000 years, I think we will begin to spread throughout the galaxy. Again, that's just based on the fact that that's what life does. It occupies all possible niches. And there are a lot of niches out there in the galaxy. We won't spread by sending rocket ships with people. We will send maybe microscopic robots with lots of information, and they will reconstruct life on those planets. Or we will send, most of what we will send will be in binary code. But eventually, one way or another, as life always does, we will spread throughout the galaxy. if we survive. So to end, science will be even more important in tomorrow's world. It will continue to reveal more of nature's secrets. It will increase our control over nature's forces. And those will have good consequences which are intended and bad that are unintended. But hopefully the culture of science will inspire us to exploit the good and avoid the bad. Thank you.
On? Okay. Thank you very much, Dr. Gross, for that fascinating lecture and for deepening our appreciation for science, for figuring out the universe, for understanding the human life on Earth, and for confronting the issues and problems that we face today. We are now ready for the open forum. And the audience in the theater, as well as our faculty, students, staff, and alumni from 9 UP campuses all over the country who are at the moment video conferencing with us, may ask Dr. Gross a few questions. As mentioned earlier, this program is on webcast, live over the internet, so our alumni all over the world who have been watching the webcast are also able to participate and ask their questions through the various chat channels that have been made available to us. Let's begin with a question or two from the audience inside the theater. If you would raise your hand, I will call you and I will ask you to approach one of the microphones on the aisles. You would kindly introduce yourself and please phrase your question as briefly as possible so we can accommodate as many questions as we possibly can. Do I see Dr. Saloma? I think Dr. Saloma. Oh, yes, please. I'm sorry, I thought it was Dr. Saloma.
Yeah, that's an honor to call
Dr.
me Dr. Saloma.
I'm here.
Okay.
Oh, I'm sorry.
Okay, good morning, Professor.
Oh, sorry.
Good morning, Professor Gross. I'm Cesar Saloma. I would like to start with the question of regarding the future of science and its traditional disciplines and the questions that you were raising, which are very interesting. Will there be an evolution of these traditional disciplines so that the questions could be answered more sensibly? The traditional disciplines of physics, chemistry, and so on. Do we need to realign them or to redefine the boundaries? So that, thank you very much.
So the question was about disciplines are just names. In 400 years ago, Newton was held the chair of natural philosophy, and he was interested in anything that was natural. These disciplines are created by universities, just to divide up things and make it easier to run the university. In the 19th century, this began, but before that, everyone was a natural philosopher or a scientist interested in all natural phenomena. And so there is no real meaningful distinction between the disciplines. In some sense, everything is physics. That's how we like to think, because physics, describes all of matter and all of phenomena. But there are people who call themselves chemists who are interested specifically in the behavior of molecules, which of course is physics, but it's a very important part of physics, so they separate off. This can cause problems and is bad in general for science. because many interesting problems are often at the borderline of these so-called different disciplines. In my department at Santa Barbara, I have two colleagues who won the Nobel Prize. They're physicists, but they won the